Hello AP Statistics students. In this video we are taking a look at something called the residual. That's going to be brand new to us, but it's a very important concept when it comes to scatter plots and regression lines. So here is our objective. We will calculate and interpret the residuals of a scatter plot and see how they are used to make a regression line. By plotting these residuals, we will assess the form of a scatter plot, and by using the standard deviation of the residuals, we will assess how well our regression line fits our data. We're going to use this residual in many, many ways. So here's our scenario for this video here. We are going to be using a data set that compares the price of a used Ford F-150 with the number of miles the truck has been driven. So here is a graph of that scatter plot for that data. We have a regression line that goes through those data points. What is the residual here? So a residual is essentially how far off the data points are from the regression line. All right, to be more specific, the residual is the distance between a data point and the regression line. How far off is the regression line from the actual data? So if you want to see a mathy equation for that, a residual is equal to the actual value, y, minus the predicted value, y hat. All right, so it's just a simple subtraction problem. We are finding the distance vertically from a point down to the regression line. How far away is that point from our regression line? So a visual of all of them. Here's the same scatter plot with all the residuals drawn. Again, we are looking at these distances right here. Those are all of our residuals. How far off are they from the predicted regression line? So let's calculate one of those. A Ford F-150 with 70,583 miles is sold for $21,994. Find and interpret the residual for this truck using the regression line. All right, so remember our residual is equal to the actual cost that it sold for, $21,994, minus the predicted value. So we have to find the predicted value for a truck that has been driven 70,583 miles. So what we have to do is take that and plug it into our regression line over here. We'll plug that 70,000 in for x and see what the predicted value over here is for y. So let's do that. I'm going to pull up my calculator. I actually already typed it in there. So 38,257 minus 0.1629 times 70,000. We're plugging in the 70,000 for x, and we get 26,759. So 26,759 is our predicted value. So now to find the residual, we subtract that from 21,994. And we get 21,994 minus second answer gives us negative 4,765. Negative 4,765. So what does that mean? Can we interpret that number? So that means this truck sold for 4,765 $765 less, because that residual is negative, it's underneath the regression line. So it sold for $4,765 less than the predicted value of a truck with 70,583 miles, according to our regression line. All right, so that's the general idea of our residual. How far away from the regression line are you? In this case, I didn't mention that before, but a negative does mean that our data point was underneath the graph. All of these residuals down here are negatives, and all the ones on top are positives. So, example 2 here. I might recommend pause the video and see if you can write the sentence for this one without me. All right? Pause the video. Do it now. Now. All right, I assume you did. So, this is our candy grab experiment. That one was a lot of fun to do. So here we have the scatter plot. We have the regression equation that we're going to use. We need to calculate the residual. So Andre has a hand span of 22, and he actually grabbed 36. So what residual does that give us? So our residual here will be equal to 36 minus the predicted value for 22 centimeters. So that will be 36 minus, pull up our calculator, negative 29.8 plus 2.83 times 22 centimeters for his hand span, 32.5. So that is a residual of 3.5. So that means that Andre was able to grab 3.5 starbursts more than the predicted value from the regression line, where x, I might even put what x is in there, where x equals 22 centimeters. 22 centimeter hand span. I like even more context is never a bad thing. Context, context, context. All right, so he was 3.5 starbursts. See there that that residual does have units. In this case, it's the number of starbursts. He was above the regression line. All right. Now that regression line, the calculator gives it to you. We've been using it to predict values, to extrapolate values. Well, we shouldn't be doing that, but we do sometimes. Where does it come from? Well, it comes from residuals. Namely, it comes from trying to minimize the residuals as much as possible. Hopefully that makes sense. You don't want your data to be far away from your prediction line, right? And so we want it to be as close to the data points as possible. Now here's where we have an issue though. If we take all the residuals and add them up, the positives will again always cancel out the negatives, and that total will always be 0. That was not a highlighter. All right, so what are we to do? Well, hopefully that situation sounds familiar to you. We had this same issue with standard deviation, where the positives were canceling out the negatives, and we're going to do the same thing. We are going to square the residuals. All right, and here's a nice diagram of that. So we take this distance here for the residual. We square it, which does mean turn it into a square. And then we add all of those squares up. And that is called the sum of squared residuals. Now, that's a huge number, of course. And what the regression line does is it angles itself, goes up and down just so that it minimizes the sum of the squared residuals. Now, you can't do that by hand. The calculator is always going to do that for you. But it's good for you to know where it comes from. That this regression line comes from putting a line in such a way that it minimizes this sum of all of these squares of the residuals. Okay? And which is why we now are going to call this oftentimes the least squares regression line. Okay, so it is sometimes referred to one way and the other, but just so you know, there's no difference. A regression line is the same thing as a least squares regression line. Now you might be thinking, Bolt, well that tells me why it's called the least squares. Where the heck did the regression come from? Yeah, you're going to have to wait a couple of days before I tell you where the word regression comes from and why that's there. Don't worry, you will be a lot younger when you figure that out than I was, because I only figured that out like a couple months ago, why the word regression is there. It's kind of cool. All right, back to residuals. What can't they do? They can do at least two more things. The next thing is if you take those residuals and you graph the residuals, what that's going to help us to do is to determine, is a linear model appropriate? All right, so first, what the heck does it look like if you graph residuals? So remember, the residual is this distance right here. Well, what if I took that distance, all right, that value, and I graphed all of those values? All right, well, some of them are going to be positive values, right? These are all positive residuals. Some of those values are going to be negative. These are all negative residuals. They're underneath the curve. What will that look like? Well, over here, we have what that looks like. So as you can see, like this point here, a very small residual because it's very close. So it's very close to 0. All right, where's a point over here? The last one here is also pretty close to the regression line, so it's also a fairly small y value over here. If I see a value with a large residual, that means that point is far away from the regression line. It's probably this one right here. That one's pretty far away from the regression line. Looks like it's in the right place. So what are we looking for when we look at a residual plot? You're looking for nothing. All right, it should look random. All right, a residual plot, what to look for? It should look random. Because some points are going to be above the regression line and some points will be low, and you want to be sort of scattered throughout. All right, it's got to go right down the center of all the points. And so some points should be above the residual plot or above 0, and some should be below 0. And they should look fairly random, namely no pattern. And if there is no pattern, that means your scatter plot is linear. So the question this helps us answer is the linear model appropriate for relating price to miles driven for our Ford F-150? And so I look at the residual plot and I see that there is no pattern there. Those points look random. I like this linear model. So I would say, yes, it is appropriate to use this linear model to relate the price of a Ford F-150 to its miles driven, because the residual plot has no pattern. I'll send that out. All right, it has no pattern. Therefore, yes, I am perfectly okay using a linear model. Now, to help that make sense, let's look at one where it is not appropriate, and I think you'll see a little bit better what this residual plot does for us. All right, so this is not the Ford F-150. This is fertility rate of a country based off of the average income of a country. Okay, so on the left, this is just the scatter plot. And hopefully from there you can see that this is not linear. It definitely has some kind of a curve. But that doesn't mean technology won't give you a linear model if you tell it to. And so it does have a linear model here, for better or worse, right there. It might even have a decent correlation value. Who knows? So is it appropriate? All right, is it appropriate to use this least square regression line to relate fertility rate to a country's average income? Well, we take a look at the residual plot. All right, and we see a definite pattern here. There is a curve to this data. It kind of still starts up here, comes down and goes up. I see a pattern. It's not random looking. That tells me that the linear model is a no-go. Can't use it here. And that's what I will use to justify saying no. Do not use this linear model. This linear model is not appropriate to relate context, these countries' fertility rates to their average income, because the residual plot has a definite curve/pattern to it. And that is a great way to say that don't use a linear model here. Can't do it. That's bad stats. All right. The power of residuals keeps going. All right. It can tell us if something is linear or not. It can also tell us how well a linear model fits a certain data set. All right. This is the last thing we got to take a look at. How well does the least squares regression model fit the data? And for this, we are going to use standard deviation. So yes, you might be thinking, well, Bolt, what about correlation? Yes, correlation does sort of tell you how linear something is, but it's just the tip of the iceberg. You can actually take a look at the standard deviation of the residuals. This is kind of like how spread out are the data values from the regression line. If they're very close to the regression line, they won't be spread out, and it'll be a very good measure. If the data values are really spread out away from the regression line, your regression line isn't as good. Remember, standard deviation is a measure of spread, and that's how I want you to think about this. How spread out from the regression line are we? So essentially what happens here is we think of all these residuals. All right, positives, negatives, etc., etc. Think of those as numbers. Okay, so here is a data set of all of those residuals as numbers. And we do to those numbers like we did in Unit 1. We calculate the standard deviation of them. Now, I gotta admit, the calculation's a little bit different, but not very much. It's still a standard deviation. So we calculate that standard deviation. And yes, calculators do it for us. So here it is. We have to interpret that standard deviation. What is it? Well, it's the typical distance away from the... but there's no mean this time, is there? So it's not away from the mean, it's away from the regression equation. The typical distance away from the regression equation. So let's interpret this 5,740, which is the standard deviation of this data set. So the actual Ford F-150, or the actual price, is typically $5,740 away from the, now I can't say mean here, right? From the predicted value by the least squares regression model, where, if I could spell, X is miles driven. All right. Hopefully a lot of that sentence sounds familiar. I did write the word dollars here on purpose just to emphasize that standard deviation does have units. All right. It does have units. So it does have dollars right here. So the actual price of a Ford F-150 is typically $5,740 away from the predicted value by the least squares regression model. And this is important that you tell me, what are we using to predict in this case, where X is miles driven? We think the miles driven will predict the price. And so with the dollars, I have the Y value sort of given context. I need to give the X value context as well. Otherwise, maybe we were just using the year model to predict, or something like that. It could have been anything. So it's important to put that bit of context into your writing. All right, let me give you one more here. Can you read this? Back to our starburst example. I want you to try to write a sentence for the standard deviation. Don't do B. We haven't talked about R squared. Spoiler. Okay. But you should be able to write a sentence for the standard deviation. Remember, that does have units. Write a sentence there. Pause the video, and then I will show you my sentence. All right, so here was my sentence. The actual number of starbursts a person can grab typically varies by 4.03 starbursts away from the number predicted by the least squares regression model, where X is equal to the hand span. All right, that was a lot, ladies and gentlemen. Let's recap everything we talked about. All right, we should now know what a residual is. All right, and how to calculate it and how to interpret it. All right, we should be able to use the residuals to assess the form. Is this scatter plot linear, by making or at least reading a residual plot. And we should be able to use the standard deviation of the residuals to assess how good or how well our regression line fits our data. 3 things there that are really important about a residual.